Q-Instruct, improving low-level visual abilities for multimodality foundation models. Multimodality foundation models, as represented by GPT-4v, have brought a new paradigm for low-level visual perception and understanding tasks that can respond to a broad range of natural human instructions in a model. While existing foundation models have shown exciting potentials on low-level visual tasks, their related abilities are still preliminary and need to be improved. In order to enhance these models, we conduct a large-scale subjective experiment collecting a vast number of real human feedbacks on low-level vision. Each feedback follows a pathway that starts with a detailed description on the low-level visual appearance, for example, clarity, color, brightness of an image, and ends with an overall conclusion, with an average length of 45 words. The constructed Q pathway dataset includes 58K detailed human feedbacks on 18,973 images with diverse low-level appearance. Moreover, to enable foundation models to robustly respond to diverse types of questions, we design a GPT-participated conversion to process these feedbacks into diverse format 200K instruction response pairs. Experimental results indicate that the Q-Instruct consistently elevates low-level perception and understanding abilities across several foundational models. We anticipate that our datasets can pave the way for a future that general intelligence can perceive, understand low-level visual appearance, and evaluate visual quality like a human. Our dataset, Model Zoo and Demo is published at Project's website. Music ControlNet, multiple time-varying controls for music generation. Text-to-music generation models are now capable of generating high-quality music audio in broad styles. However, text control is primarily suitable for the manipulation of global musical attributes like genre, mood, and tempo, and is less suitable for precise control over time-varying attributes such as the positions of beats in time or the changing dynamics of the music. We propose Music ControlNet, a diffusion-based music generation model that offers multiple precise, time-varying controls over generated audio. To imbue text-to-music models with time-varying control, we propose an approach analogous to pixel-wise control of the image domain ControlNet method. Specifically, we extract controls from training audio yielding paired data and fine-tune a diffusion-based conditional generative model over audio spectrograms given melody, dynamics, and rhythm controls. While the image domain uni-ControlNet method already allows generation with any subset of controls, we devise a new strategy to allow creators to input controls that are only partially specified in time. We evaluate both on controls extracted from audio and controls we expect creators to provide, demonstrating that we can generate realistic music that corresponds to control inputs in both settings. While few comparable music generation models exist, we benchmark against MusicGen, a recent model that accepts text and melody input, and show that our model generates music that is 49% more faithful to input melodies despite having 35x fewer parameters, training on 11x less data, and enabling 2 additional forms of time-varying control. Sound examples can be found at Project's website. ChatAnything Facetime chat with LLM-enhanced personas. In this technical report, we target generating anthropomorphized personas for large language models, LLMs, based characters in an online manner, including visual appearance, personality, and tones, with only text descriptions. To achieve this, we first leverage the in-context learning capability of LLMs for personality generation by carefully designing a set of system prompts. We then propose 2 novel concepts: the mixture of voices, MoV, and the mixture of diffusers, MoD, for diverse voice and appearance generation. For MoV, we utilize the text-to-speech algorithms with a variety of predefined tones, and select the most matching one based on the user-provided text description automatically. For MoD, we combine the recent popular text-to-image generation techniques and talking head algorithms to streamline the process of generating talking objects. We termed the whole framework as ChatAnything. With it, users could be able to animate anything with any personas that are anthropomorphic, using just a few text inputs. However, we have observed that the anthropomorphic objects produced by current generative models are often undetectable by pre-trained face landmark detectors, leading to failure of the face motion generation, even if these faces possess human-like appearances, because those images are nearly seen during the training, for example, out-of-distribution samples. To address this issue, we incorporate pixel-level guidance to infuse human face landmarks during the image generation phase. To benchmark these metrics, we have built an evaluation dataset. Based on it, we verify that the detection rate of the face landmark is significantly increased from 57.0% to 92.5%, thus allowing automatic face animation based on generated speech content. The code and more results can be found at the project's website. Story to motion, synthesizing infinite and controllable character animation from long text. Generating natural human motion from a story has the potential to transform the landscape of animation, gaming, and film industries. A new and challenging task, story to motion, arises when characters are required to move to various locations and perform specific motions based on a long text description. This task demands a fusion of low-level control, trajectories, and high-level control, motion semantics. Previous works in character control and text-to-motion have addressed related aspects, yet a comprehensive solution remains elusive. Character control methods do not handle text description, whereas text-to-motion methods lack position constraints and often produce unstable motions. In light of these limitations, we propose a novel system that generates controllable, infinitely long motions and trajectories aligned with the input text. 1. We leverage contemporary large language models to act as a text-driven motion scheduler to extract a series of text position duration pairs from long text. 2. We develop a text-driven motion retrieval scheme that incorporates motion matching with motion semantic and trajectory constraints. 3. We design a progressive mask transformer that addresses common artifacts in the transition motion, such as unnatural pose and foot sliding. Beyond its pioneering role as the first comprehensive solution for story-to-motion, our system undergoes evaluation across 3 distinct subtasks: trajectory following, temporal action composition, and motion blending, where it outperforms previous state-of-the-art motion synthesis methods across the board. The project's website. GPT-4V in Wonderland, large multimodal models for zero-shot smartphone GUI navigation. We present Navigator, a GPT-4V-based agent for the smartphone graphical user interface, GUI, navigation task. Navigator can interact with a smartphone screen as human users and determine subsequent actions to fulfill given instructions. Our findings demonstrate that large multimodal models, LMMs, specifically GPT-4V, excel in zero-shot GUI navigation through its advanced screen interpretation, action reasoning, and precise action localization capabilities. We first benchmark Navigator on our collected iOS screen dataset. According to human assessments, the system exhibited a 91% accuracy rate in generating reasonable action descriptions and a 75% accuracy rate in executing the correct actions for single-step instructions on iOS. Additionally, we evaluate the model on a subset of an Android screen navigation dataset, where the model outperforms previous GUI navigators in a zero-shot fashion. Our benchmark and detailed analyses aim to lay a robust groundwork for future research into the GUI navigation task. The project page is at the project's website. SPHINX, the joint mixing of weights, tasks, and visual embeddings for multimodal large language models. We present SPHINX, a versatile multimodal large language model with a joint mixing of model weights, tuning tasks, and visual embeddings. First, for stronger vision-language alignment, we unfreeze the large language model during pre-training and introduce a weight mix strategy between language models trained by real-world and synthetic data. By directly integrating the weights from 2 domains, the mixed language model can efficiently incorporate diverse semantics with favorable robustness. Then, to enable multi-purpose capabilities, we mix a variety of tasks for joint visual instruction tuning and design task-specific instructions to avoid inter-task conflict. In addition to the basic visual question answering, we include more challenging tasks such as region-level understanding, caption grounding, document layout detection, and human pose estimation, contributing to mutual enhancement over different scenarios. Additionally, we propose to extract comprehensive visual embeddings from various network architectures, pre-training paradigms, and information granularity, providing language models with more robust image representations. Based on our proposed joint mixing, SPHINX exhibits superior multimodal understanding capabilities on a wide range of applications. On top of this, we further propose an efficient strategy aiming to better capture fine-grained appearances of high-resolution images. With a mixing of different scales and high-resolution sub-images, SPHINX attains exceptional visual passing and reasoning performance on existing evaluation benchmarks. We hope our work may cast a light on the exploration of joint mixing in future multimodal research. Code is released at the project's website. To see is to believe, prompting GPT-4v for better visual instruction tuning. Existing visual instruction tuning methods typically prompt large language models with textual descriptions to generate instruction-following data. Despite the promising performance achieved, these descriptions are derived from image annotations, which are oftentimes coarse-grained. Furthermore, the instructions might even contradict the visual content without observing the entire visual context. To address this challenge, we introduce a fine-grained visual instruction dataset, LLM-Instruct 4v, which contains 220K visually aligned and context-aware instructions produced by prompting the powerful GPT-4v with images from LLM. Through experimental validation and case studies, we demonstrate that high-quality visual instructional data could improve the performance of Llama 1.5, a state-of-the-art large multimodal model, across a wide spectrum of benchmarks by clear margins. Notably, by simply replacing the LLM-Instruct with our LLM-Instruct 4v, we achieve better results than Llama on most challenging LM benchmarks. For example, Llama W 76.7 versus 70.7, and MMVet 40.2 versus 35.4. We release our data and model at the project's website. Towards general-purpose speech abilities for large language models using unpaired data. In this work, we extend the instruction-tuned Llama 2 model with end-to-end general-purpose speech processing and reasoning abilities, while maintaining the wide range of LLM capabilities, without using any carefully curated paired data. The proposed model can utilize audio prompts as a replacement for text and sustain a conversation. Such a model also has extended cross-modal capabilities, such as being able to perform speech question answering, speech translation, and audio summarization amongst many other closed and open domain tasks. This is unlike prior approaches in speech, in which LLMs are extended to handle audio for a limited number of pre-designated tasks. Experiments show that our end-to-end approach is on par with or outperforms a cascaded system, speech recognizer plus LLM, in terms of modeling the response to a prompt. Furthermore, unlike a cascade, our approach shows the ability to interchange text and audio modalities and utilize the prior context in a conversation to provide better results. The impact of large language models on scientific discovery, a preliminary study using GPT-4. In recent years, groundbreaking advancements in natural language processing have culminated in the emergence of powerful large language models, LLMs, which have showcased remarkable capabilities across a vast array of domains, including the understanding, generation, and translation of natural language, and even tasks that extend beyond language processing. In this report, we delve into the performance of LLMs within the context of scientific discovery, focusing on GPT-4, the state-of-the-art language model. Our investigation spans a diverse range of scientific areas encompassing drug discovery, biology, computational chemistry, density functional theory, DFT, and molecular dynamics, MD, materials design, and partial differential equations, PDE. Evaluating GPT-4 on scientific tasks is crucial for uncovering its potential across various research domains, validating its domain-specific expertise, accelerating scientific progress, optimizing resource allocation, guiding future model development, and fostering interdisciplinary research. Our exploration methodology primarily consists of expert-driven case assessments, which offer qualitative insights into the model's comprehension of intricate scientific concepts and relationships, and occasionally benchmark testing, which quantitatively evaluates the model's capacity to solve well-defined domain-specific problems. Our preliminary exploration indicates that GPT-4 exhibits promising potential for a variety of scientific applications, demonstrating its aptitude for handling complex problem-solving and knowledge integration tasks. Broadly speaking, we evaluate GPT-4's knowledge base, scientific understanding, scientific numerical calculation abilities, and various scientific prediction capabilities. Go to anything. In deployment scenarios such as homes and warehouses, mobile robots are expected to autonomously navigate for extended periods, seamlessly executing tasks articulated in terms that are intuitively understandable by human operators. We present Go to Anything, GOAT, a universal navigation system capable of tackling these requirements with three key features. A. Multimodal. It can tackle goals specified via category labels, target images and language descriptions. B. Lifelong. It benefits from its past experience in the same environment. And C. Platform. Agnostic, it can be quickly deployed on robots with different embodiments. GOAT is made possible through a modular system design and a continually augmented instance-aware semantic memory that keeps track of the appearance of objects from different viewpoints in addition to category-level semantics. This enables GOAT to distinguish between different instances of the same category to enable navigation to targets specified by images and language descriptions. In experimental comparisons spanning over 90 hours in 9 different homes, consisting of 675 goals selected across 200+ different object instances, we find GOAT achieves an overall success rate of 83%, surpassing previous methods and ablations by 32%. Absolute improvement. GOAT improves with experience in the environment, from a 60% success rate at the first goal to a 90% success after exploration. In addition, we demonstrate that GOAT can readily be applied to downstream tasks, such as pick and place and social navigation. MEGAVERSE, benchmarking large language models across languages, modalities, models, and tasks. Recently, there has been a rapid advancement in research on large language models, LLMs, resulting in significant progress in several natural language processing, NLP, tasks. Consequently, there has been a surge in LLM evaluation research to comprehend the model's capabilities and limitations. However, much of this research has been confined to the English language, leaving LLM building and evaluation for non-English languages relatively unexplored. There has been an introduction of several new LLMs, necessitating their evaluation on non-English languages. This study aims to expand our MEGA benchmarking suite by including 6 new datasets to form the MEGAVERSE benchmark. The benchmark comprises 22 datasets covering 81 languages, including low-resource African languages. We evaluate several state-of-the-art LLMs like GPT-3, 5 Turbo, GPT-4, Palm 2, and Llama 2 on the MEGAVERSE datasets. Additionally, we include 2 multimodal datasets in the benchmark and assess the performance of the Lava V1. 5 model. Our experiments suggest that GPT-4 and Palm 2 outperform the Llama models on various tasks, notably on low-resource languages, with GPT-4 outperforming Palm 2 on more datasets than vice versa. However, issues such as data contamination must be addressed to obtain an accurate assessment of LLM performance on non-English languages. Cappy, outperforming and boosting large multitask LMs with a small scorer. Large language models, LLMs, such as T0, FLAN, and OptIML, excel in multitasking under a unified instruction-following paradigm, where they also exhibit remarkable generalization abilities to unseen tasks. Despite their impressive performance, these LLMs, with sizes ranging from several billion to hundreds of billions of parameters, demand substantial computational resources, making their training and inference expensive and inefficient. Furthermore, adapting these models to downstream applications, particularly complex tasks, is often unfeasible due to the extensive hardware requirements for fine-tuning, even when utilizing parameter-efficient approaches such as prompt tuning. Additionally, the most powerful multitask LLMs, such as OptiIML 175B and FLAN Palm 540B, are not publicly accessible, severely limiting their customization potential. To address these challenges, we introduce a pre-trained small scorer, Cappy, designed to enhance the performance and efficiency of multitask LLMs. With merely 360 million parameters, Cappy functions either independently on classification tasks or serve as an auxiliary component for LLMs, boosting their performance. Moreover, Cappy enables efficiently integrating downstream supervision without requiring LLM fine-tuning nor the access to their parameters. Our experiments demonstrate that when working independently on 11 language understanding tasks from prompt source, Cappy outperforms LLMs that are several orders of magnitude larger. Besides, on 45 complex tasks from Big Bench, Cappy boosts the performance of the advanced multitask LLM FLAN T5 by a large margin. Furthermore, Cappy is flexible to cooperate with other LLM adaptations, including fine-tuning and in-context learning, offering additional performance enhancement. LayoutPrompter, Awaken the designability of large language models. Conditional graphic layout generation, which automatically maps user constraints to high-quality layouts, has attracted widespread attention today. Although recent works have achieved promising performance, the lack of versatility and data efficiency hinders their practical applications. In this work, we propose LayoutPrompter, which leverages large language models, LLMs, to address the above problems through in-context learning. LayoutPrompter is made up of three key components, namely input-output serialization, dynamic exemplar selection, and layout ranking. Specifically, the input-output serialization component meticulously designs the input and output formats for each layout generation task. Dynamic exemplar selection is responsible for selecting the most helpful prompting exemplars for a given input. And a layout ranker is used to pick the highest quality layout from multiple outputs of LLMs. We conduct experiments on all existing layout generation tasks using 4 public datasets. Despite the simplicity of our approach, experimental results show that LayoutPrompter can compete with or even outperform state-of-the-art approaches on these tasks without any model training or fine-tuning. This demonstrates the effectiveness of this versatile and training-free approach. In addition, the ablation studies show that LayoutPrompter is significantly superior to the training-based baseline in a low-data regime, further indicating the data efficiency of LayoutPrompter. Our project is available at the project's website. Trusted source alignment in large language models. Large language models, LLMs, are trained on web-scale corpora that inevitably include contradictory factual information from sources of varying reliability. In this paper, we propose measuring an LLM property called Trusted Source Alignment, TSA, the model's propensity to align with content produced by trusted publishers in the face of uncertainty or controversy. We present FactCheck QA, a TSA evaluation dataset based on a corpus of fact-checking articles. We describe a simple protocol for evaluating TSA and offer a detailed analysis of design considerations, including response extraction, claim contextualization, and bias in prompt formulation. Applying the protocol to Palm 2, we find that as we scale up the model size, the model performance on FactCheck QA improves from near random to up to 80% balanced accuracy in aligning with trusted sources.